Hi everyone. Thanks for making it this morning. I am one of the maintainers and co-founders of Deploy, and I'm going to focus a big chunk of the conversation around, like thinking about testing practically, like in our, in our daily lives, in our daily work environments, and what are some things that I've learned over the years. So as an outline, first we'll go with some brief theory about the theoretical models, and then we'll touch base on, how do we actually test in real life? What is the problems? How can we deal with them? And then a practical use case of AI and LLMs. What is it really good at, and what can we actually, and where we should probably not use it, right? So just to set the stage, this is the standard testing pyramid. I hope everybody's aware. Just a quick refresher. This became popular in about 2009, and essentially what it says is you must have more unit tests because they execute faster, they are quicker to write, and then you should have the next stage will be the integration tests, which provide more value but are harder to write and also take more time to execute, and then we have the E2E or manual testing on top of that. So yeah, nowadays some of you might know this, we have something called the testing trophy and the testing honeycomb. Different companies started making this popular. Basically, the idea is, we should have more integration tests. That's the basic takeaway. And what people say is that if you have more integration tests than your unit and E2E, that's a more maintainable and a long-term and a sustainable way to test. Both are different versions of the same thing. Static here just means static analysis. They just put it there because the JavaScript audience, they have static checkers now, like TypeScript and the like. So that's also very important, right? That's definitely should be there. That's basically the high-level idea. So, after reading about this, the first question that came to my mind was, is the testing period obsolete, right? Is it old? Has the world changed? What's really happened? So, spoiler alert, it's not, right? It's definitely 15 years old, but it's not yet obsolete. Why? Because it all depends on how you define integration versus unit testing, right? So just random ideas. Can anybody define the difference between integration and unit testing? There's no standard definition. It just varies quite a bit. But can anybody share your understanding?
So there is a unit. There's a component which we need to test, or a function which we need to test. Then it's unit testing. So we test the custom inputs. What is the expected output? It should be same. That is unit testing. And integration testing is where different units of code are tested. How they behave when both the units are tested. Both the units are working at the same time.
That's a great definition. So just for everyone to hear, what he said is unit testing is testing a unit independently, and integration is testing those independent units together, right? And to see if they still work. The problem is when this definition was created, right, by the folks at ThoughtWorks, the way they defined unit was not based on the code. It was more on who is doing it. Like for example, if I'm a developer and I'm going to test something, what I'm working on is my unit, right? And I'm supposed to test my unit. I'm supposed to write the test case for that. So I might be working on a larger piece of code. So then my definition of unit test changes. Integration tests happen when multiple developers merge together, and then we checked if those individual units still work together. So it was never that, I'm going to test a function or I'm going to test a class. It was more on, can I test one person's work independently? And can that person quickly verify and test his independent work or his or her independent work? So that's basically the idea. So Martin Fowler, he wrote about it. He's a popular guy at ThoughtWorks. And basically his definition was that, look, when we made the testing pyramid, what most people refer to as integration tests are basically sociable unit tests. What does that mean is, you have a unit which interacts with other units, right? And that's okay. You can have a unit which relies on other unit, and that can be part of your system under test. So that's a sociable test. And the standard unit test that we call is, the solitary unit test. So you're testing everything in isolation. every other component classes are mocked. So yeah, that's basically what he came up with, and he said testing pyramid is not obsolete. It's just the way people look at things were wrong. So yeah, I mean, the next thought I had in my mind after that was, okay, yeah, so we're back to square one, right? So what do we do, right, after all this knowledge? I guess the idea is to redefine the testing pyramid. So instead of, because now we have unit testing libraries after that, and most of us are used to writing, tests for a particular class or for a particular method. So I think we're associating things the wrong way. So maybe we can redefine it and say, small, medium, hard, right? Small, you can write it very quickly, you can test it very quickly, and they're typically testing components that individual developers working on, right? Medium, multiple developers. Large, the entire programming, including the UI, everything, right? So that's that. So yeah, so this is the definition that I'll be sticking to for the remainder of this talk. But yeah, this is what happens in practicality, right? So many of us, in many of our companies, when we start a project, maybe there's no test. Then we introduce some manual testing, right? We start with that and it makes sense. It's a good starting point, right? And it's driven by business impact, because if you go back to the testing pyramid, the complex test cases deliver the most value, but they are the most complex to write and maintain. They're very difficult. So yeah, so because it's driven by business impact and business stakeholders, initially started manual testing. Then we realized, okay, manual testing is not scalable. Let's write automated tests. But we never end up automating everything. The average industry automation is 22-23%. And after some point in time, I think then some proponents in the team or in the company start realizing that, okay, that's not scalable. Let's start testing ourselves. And that's when some people would introduce unit tests and integration tests. So that's the typical journey we've seen, and it happens not just in India, but globally. It happens at all companies. It's just driven by business. The problem is, like we said, it's not scalable, right? As we keep adding things to the application, as we keep adding team members, we cannot. I mean, the amount of work for manual testing and E2E testing grows exponentially. So yeah. So what do we do, right? I mean, we're all in this problem. So what do we do? We need to invert the code, right? That's the theory. Okay, can we change it? Can we start doing the right thing? How do we do the right thing? Approach one, right? That's I have seen and I've tried in the past. We introduce a program that, from today everybody is going to write unit tests, and we're going to maintain a gating, and we're going to have minimum test coverage, and we're like, okay, let's teach everybody how to write tests. Let's introduce some frameworks. Let's add it to the CI, and then we start rolling. And then we have business priorities. Sometimes it gets deprioritized. And yeah, I mean, sometimes it works, sometimes it doesn't, right? Depends on the team. And yeah, I mean, in the teams that I have worked with, it was a bit too annoying. It slowed us down too much. And that's why we thought, what if there's a better way, right? There has to be something. So yeah, that's where we start taking inspiration from some of the work larger companies are doing, right? How are they testing? Like, is it like, do they have unit tests for literally everything? While we may think yes, for a lot of cases not really, right? It's like one of those things like TDD, where we think, okay, TDD is great, let's do TDD, but it's not practically followed because we all need to move fast and deliver. So that's the approach too. You know what? We already have manual tests, probably, if it's an application anybody cares about. And we already probably would have large and medium tests with us. So can I convert them into sociable unit tests, or what we call integration tests? Right? If I do that, maybe that can easily help me invert the code. So yeah, that's where we kind of started, and that's how Kepler started. So the idea was, okay, can I convert my existing test cases to something? Okay. Yeah, so something that's extremely fast. And yeah, I mean, on high level you can read more about it, but yeah, Kepler essentially would record ticks, so you could run your existing manual or automated test. You can record this, whatever they're doing, and you can create a test that runs extremely fast and doesn't require any foreign components like databases and things. So that's a high level. You can obviously read more about it. So yeah, I'd love to show it you quickly. I think we have some time for demo. So as a demo, I'm taking a sample which is already available on Kepler samples GitHub repository, and a simple pet clinic application. So I'll delete the folder from my previous test run, my previous recorded tests. So yeah, here I have an application. It's not really integrated with Kepler. It's a simple Spring Boot. It's the pet clinic application. It's the popular sample pet clinic application. And what I'm going to do is I'm going to run deploy record and just the application command to run it. Simple Java. So essentially, what I'm going to do is I'm going to use deploy to run the application and either run the manual test, which I might have, or run the automated test, which may take hours and has a lot of flakiness. So yeah, application is started. Now when I go to the UI, maybe I'll just create a new owner. Right. So. Yeah, and then I can so I did a bunch of things. Maybe this could be a manual or automated test. And as you can see, those things get recorded as part of deploy. Now to run these, I can just clear a thing and run these tests. While these tests start, we can quickly go through what the tests look like. So we can see options call, we can ignore. We have a post call, which we had created a user. You can see Raju saying, right? We had the details, getting the owners, searching for a particular thing, and we can see the request response already captured. What's special is, and what makes it something that's faster is, we also have the Postgres mocks. So, for example, if I search Raju here, you can see this is the actual data row that's returned by the database. So I might also be able to find the insert query. So this is the insert into owners query, which is fired from the application. So when I actually run these tests, I don't need my actual database. So these would run extremely fast, right? So as you can see, these tests have passed. If I change something, like for example, I could change, maybe when I'm getting Raju, I could change this to Shubham. And yeah, that should basically fail these tests. So essentially what we did is we had, let's say, a manual test suite or an automated test suite, and we converted that into a test suite which runs extremely fast, right? And doesn't depend on any live dependency, so there's less flakiness. It doesn't depend on a real database, it doesn't depend on anything. Everything is captured and replayed. Yeah, as you can see, here we have that test report. That instead of Raju, we have Shubham now, right? So yeah, so that's an example. Now, coming to the practical usage, right? So this is like, okay, you know what, I have my existing test suite, but something else that has been changing the world is LLMs, right? Machine learning. So that's that. So that's pretty exciting, actually. And here I'll quickly go over the pros and cons. What I see, first cons, I feel that when it comes to E2E or integration tests, LLMs do not yet have great context. It might be able to read some file and maybe generate some tests for you, but when it comes to, let's say, the kind of test that we just created, it would not be really good, because it has to understand the interactions the application is doing, especially in a large system. It needs to understand the interaction that's happening with a large, like with multiple databases, with multiple services. So at least for the next maybe, I could be wrong, I don't know, but as of what I see right now, the context is quite limited. And they don't really, like most LLMs do not really understand the execution complexity. They're all static, so it happens before the application runs. And they require extensive manual review. You cannot just, generate tests with ChatGPT and call it a day. You really do understand what it actually did. It might have made up libraries which don't exist. I've seen that quite a lot. So yeah, requires extensive manual review. Pros can be great at finding edge cases. So I think that's something that I'll be showing right after this. That okay, while with a traditional LLM, it might be I need to review my code that's been generated. I need to ensure that I'm not going to generate extremely large and like an API test or something like that. Maybe can I use it for something else? So there, I think it's great at finding edge cases, great at reasoning, right? Like if I would give it, let's say the files are kept are generated, it will be able to look at that and give you a very good reason why something failed, or what could have gone wrong. Great at guessing things. So yeah, so that's what we feel that, especially in testing, because testing is something we all want to be confident on, and I cannot be confident on something which I have no idea what's going to generate, right? So I feel when it comes to writing integration or sociable unit tests, machine learning models, LLM models can be used in a great way, but it requires a great orchestration system which is doing the heavy lifting, right? So I'll show an example. So in the previous example that we saw, we manually did the calls, right? And so if I go back, we manually did the calls and we generated tests as well as stubs, right? Now this could be external API calls instead of Postgres queries, it could be anything else, whatever the application is talking to. And then the actual test cases, what we perform. These could also be generated using LLMs. Basically, the input can be generated by LLMs, and rest we can just leverage the existing platform. So that way we know that whatever is being generated is definitely correct, right? And we can also leverage code coverage metrics to figure out, okay, which are redundant. Even when you're writing tests manually, it can become very annoying when we have too many tests written by different people in the team, and they are overlapping, and they slow the system down. So those things can be baked into the platform to ensure that we have very high quality tests and they run fast. So, so in this case, what I'm going to do is, like in case of Keploy, we can use LLMs to generate tests, and there you can provide again the application and an application schema, right, as a reference. So essentially, it's going to do the exact same thing, except instead of me having to, invoke the application vehicle or the UI, it's all going to happen using the LLM model. So that would do all that, test generation and stuff. So yeah, as you can see, it has already started to generate these tests, and we'll also inspect them. Okay, let's see what's actually doing. So, like in this case, it's trying to, like this is an employee's API, so it's trying to get the API. Body is empty, great. If I look at another example, it's trying to post something, and it's trying random things. It's trying to put a number in the first name, last name, right? It tried some other things here. It's trying a smaller letter. Here, I think it's trying a base 64 and non-ASCII character, just to see if the application would break or how it would react. So yeah, a bunch of those things. It's going to try all that. It's going to see, does it increase the branch coverage, right? And then finally, you'll have a test suite, which can find edge cases for you, right? Again, it's not supplement for thinking of test cases. I think that's still very, very valuable, but can be a good way to find edge cases, right? So yeah, that's roughly it. It's already found 300. I think it stops at around 330-ish. So yeah, while that's going on, I am now happy with the questions. So yeah, question time.
This tool only supports API, and also we can use it for mobile automation.
Right now only API. But yeah, the same concept can be extended to mobile as well, but for now only APIs.
So, so you told it's Kepler is capturing the network pulse, right?
Yes.
So the data that is what P-SQL is returning. So you capture those P-SQL calls as well.
Yes. So essentially, it's like instead of the basic idea came from when we're trying to do this in production, right? Now in production, earlier we tried to take a snapshot of the entire database, rerun those calls, and to ensure that okay, those tests actually run. But when we had lots of microservices, each having multiple terabytes of data, it became impractical, and so we were like, okay, let's just replay just the database calls, and the database calls would be in MBs, right, instead of terabytes. So it would be extremely fast because the real database is not invoked, but I would know if my application is working correctly. Because if something goes wrong with the database layer or the ORM on the application, again it would fail. So yeah.
What telephone model do you use?
So right now it's a combination. So we're trying to look at both using Google's Gemini model, right? As well as for understanding schema, we have a custom LLM model which does that. So yeah, combination of both.
Yeah. So is it just for SQL DBs or we can use it?
Yeah, you can use it Mongo. You can try Redis. Works with basically everything.
Where is Keploy getting the context of the application?
In
with respect to this AI test that is getting generated. So how is it reading?
So, so the question is, how do we get context? The way it works is we provide the API schema. So using the API schema, I'm able to find the different edge cases, or another way could be you provide some existing tests. So that way, the LLM model is great at guessing, okay, you know what, this is what the API schema looks like, this is how things are connected, and this is what existing test cases are, how can I break it, right? So it will just try to form, okay, what input can I use to break it? Actual generation is done by Keploy.
So when it comes to schema, are we specifically looking at OpenAPI?
Yes.
spec?
OpenAPI, I think we're also adding support for GraphQL. gRPC is also ongoing. So yeah, so far Swagger 2 and OpenAPI 3.
Okay. Let's say we have an application, we just have an OpenAPI spec and we don't want to mock the database calls.
I think we
Can
can
we
use
do
the
that?
night.
Oh yeah, definitely.
I think.
Thank you. So I was saying, say you have an old application, you have an OpenAPI spec, the local setup is not there, but here and there you keep making changes and to push it. So can you just generate test on the basis of OpenAPI spec and not worry about database mocks?
I mean, you can, but then you have to also ensure that it is idempotent, right? For example,
that is right.
like here I was creating a user, I cannot create it twice. But if I'm using Keploy for mocking it, then I can create it twice because it will just rerun the previous request.
So basically it intervenes to connect to the database.
Yes, yes.
So it could be multiple databases and
Definitely.
and if something involves queues and something like that.
Yes, so that is also supported technically, but what we have to really look into there is will it affect the actual response of the test. Like for example, if I'm going to test an API, the queue may be async, right? It might be processed by some like an external component. So that will be a different system under test. Here is the boundaries around the application only.
If you don't mind, I have another set of different question. There is most of the responses that we see was generally JSON body and JSON output. Let's say you are returning a buffer. I have an API where let's say you put something and it returns a PDF. Okay. Is there a way we can test those sort of things? Like
I think there you may have to write a custom assertion because yeah, we can test if the buffer is exactly same, but I don't know if that's sufficient for that use case.
Yeah, because sometimes buffer might not be exactly the same because while packaging the PDF something else might not change.
I think that's a great use case of adding a custom assertion, right? So you can override what so Keploy is like a batteries included platform. You're like, okay, don't compare everything. I want to do it myself, then you can do it yourself. You can write a custom assertion based on PDF, like what you want to compare.
Yeah.
Cool, I think I'm basically done with time. Thanks everyone. I hope you enjoy the day and the ongoing talks. We're very excited. See you all soon. Thank you.